Okay, let's continue our lesson in deriving the area of a convex polygon. So, last time or in the past video, we get the area of the red trapezoid, the area of the green trapezoid, and the area of the yellow trapezoid. We use this to get the area of the triangle P1, P2, and P3. P1, P2, P3. So, let's display it again. All the areas that we gathered a while ago. So this time, let's recall, to get the area of the triangle, it is simply the area of the red trapezoid minus the sum of the area of the green trapezoid and the yellow trapezoid. Okay, let's substitute all of this. So the area of red is 1/2 times the quantity of x sub 2 minus x sub 3 times the quantity of x sub 3 plus y sub 2 minus the quantity of the areas of each trapezoid, the green and the yellow trapezoid. So for the green one, we have 1/2 times the quantity of x minus x sub 1 minus x sub 3 times the quantity of y sub 3 plus y sub 1 plus 1/2 times the quantity of x sub 2 minus x sub 1 times the quantity of y sub 1 plus y sub 2. Simplifying the expression, so we distribute the negative sign here. So this would be minus 1/2 times the quantity of x sub 1 minus x sub 3 times the quantity of y sub 3 plus x sub 1. And then distribute again the negative here, so this becomes minus. Then, since all of them have a factor of 1/2, so we can just simply factor out 1/2. So what will he have? This one. 1/2, so we factored out 1/2 and then distribute the signs. So this would be the quantity of x sub 2 minus x sub 3 times the quantity of y sub 3 plus y sub 2 minus the quantity of x sub 1 minus x sub 3 times the quantity of y sub 3 plus y sub 1 minus the quantity of x sub 2 minus x sub 1 times the quantity of y sub 1 plus y sub 2. Okay, so this is what we have a while ago. So we will just get the product of each of this group using the FOIL method. So we will have this, x sub 1/2 of x sub 2 times x sub 3 plus x sub 2 times y sub 2 minus x sub 3 y sub 3 minus x sub 3 y sub 2 minus x sub 1 y sub 1 minus x sub 3 y sub 3 plus, because minus, negative, negative, positive times positive, so that becomes positive, x sub 3 y sub 1. And negative times negative, positive times positive is positive, so that becomes x sub 3 y sub 3 plus this one, x sub 3 y sub 3 and then x sub 3 y sub 1 minus x sub 2 times y sub 1 minus x sub 2 y sub 2. Then negative, negative, positive, x sub 1 times y sub 1, so that's x sub 1 y sub 1, negative times negative, positive, x sub 1 times x sub 2, so that becomes x sub 1 y sub 2. Now, Looking at this one, we can cancel some terms. And what are those terms that we could cancel? We could cancel negative x of 3 y sub 3 and positive x of 3 y sub 3. This one. We can cancel negative x sub 1 y sub 1 and positive x sub 1 y sub 1. And we could cancel x of 2 y sub 2 and negative x of 2 y sub 2. There. Then we will have this. Rearranging these terms, wherein we can combine all the terms having the same sign. So we will have, and factoring out the negative part of each negative terms, we will have the sum of this minus the sum of this. So 1/2 x times the quantity of x sub 1 y sub 2 plus x sub 2 times y sub 3 plus x sub 3 times y sub 1 minus the quantity of x sub 2 y sub 1 plus x sub 3 y sub 2 plus x sub 1 times y sub 3. So what can you notice about this? Let's have this particular matrix. So remember the determinant, product down minus product up. So if we want to get the determinant of this particular matrix, then we could just simply get the product down. What are the product down? X sub 1 times y sub 2, which is this term. X sub 2 times y sub 3, which is this term. X sub 3 times y sub 1, which is this term. And then product up. What's the product up? X sub 2 y sub 1, x sub 3 y sub 2, x sub 1 y sub 3, which is this. So let's see. Product down, you add them together, minus the sum of all the products of up. Product up. So product down, add all of them, minus the sum of the product up. Okay. This time, we can now generalize the area of any convex polygon having a specific n vertices. Okay, so the formula of a convex polygon with n vertices is simply 1/2 the determinant of a matrix given the coordinates of each vertices, x sub 1 until x sub n, then you copy x sub 1, y sub 1 at the last entry for the column. So we just get the determinant of this divided by 2, or 1/2 the determinant of this. Again, what's a determinant? A determinant is simply product, the sum of the products down, minus the sum of the product up. Product down, product down, product down, product down, product down, until minus the sum of the product up, product up, product up, product up. Or that would be 1/2 times the quantity of the sum of x sub 1 times x sub 2 plus x sub 2 times x sub 3 plus x sub 3 times y sub 4 and so on until x sub n y sub 1 minus the quantity of y sub 1 times x sub 2 plus y sub 2 times x sub 3 plus y sub 3 times x sub 4 and so on until y sub n times x sub 1. Okay. Again, product down, add all of this, minus product up, then add all minus the sum of all product up. But we have to consider the order of the vertices. Why? The arrangement of the vertices of a polygon should be in counterclockwise direction. Counterclockwise. What is a counterclockwise direction? If you don't know, just look at your watch and it should be the opposite direction of the second hand. Okay, let's have some examples. Oh, I only have one example in this particular lesson. Find the area of the quadrilateral MATH with vertices M 5, 5, A 4, -1, C -1, -3, H -4, 7. So what is the first thing that we need to do? First is we get or plot the points MATH. So plotting the points, this would be the points. Let me have a pen. Where's the pen? I don't have pen with me. Okay, so I cannot access the pen. But this is the vertex. M, A, T, and H. Okay? Okay. MATH. We cannot connect. Okay, I have here a pen. So this is the quadrilateral. Sorry, I'm not having a steady hand right now. Oops. Anyway, there. Okay, let's assume that those are straight edges. So in this case, this is our quadrilateral MATH. So counterclockwise direction. So if we want to start with this particular point, or we let this one as our x sub 1, x sub 1, y sub 1, okay? So counterclockwise direction would be starting here, going to here. Then here. Then this. Then go back again here. Okay? So this would be our x sub 1, y sub 1, x sub 2, y sub 2, x sub 3, y sub 3, and x sub 4, y sub 4. So the area. Area is simply the 1/2 the determinant of these matrices. X sub 1, x sub 2, oh, this should be x sub 3. Okay. X sub 1, x sub 2, x sub 3, x sub 4, x sub 1, y sub 1, y sub 2, y sub 3, y sub 4, and y sub 1. Okay, so I started with this one, so counterclockwise, M, H, C, and A. So 5, 5, -4, 7, -1, -3, 1, -4, -1, and 5, 5. Back to 5, 5. So down, sum, get the sum. So 5 times 7, -4 times -3, plus -1 times -1, plus 4 times 5. Then up, add. So minus the sum of these products of the yellow, orange arrows. So that would be the one. Then compute